Good afternoon. This is the video for lesson 1-2 in algebra. On page 32 of your textbook, there's a number of vocabulary words that we end up talking today about. I'm going to go out of order though. First of all, we want to know if something is a function or not. Okay? So a function is something that passes the vertical line test. Okay, so if I look at, and I gotta click back through here, all of these graphs, these are on page 19 through 25 or 26 or something of your textbook. If I look through all of these graphs, some of these graphs are not a function because they fail the vertical line test. So for example, E fails the vertical line test. I can draw, well, that's not my straightest line, but it's a vertical line, and it crosses this circle at 2 spots. This is not a function. Okay, J. Okay, I can draw actually multiple areas. Not a function. Let's find another one. N. Not a function. Okay. R. R is a graph of a vertical line. So the entire graph is a failure of the vertical line test. Okay. When we did our warm-up in class yesterday, alright, we drew in these vertical lines at x equals 2. And you can see where it crosses 2 times on that graph. It is not a function. You can also see that 2 x values for 2 different y values. So the x value of 2 got used twice. Once to be at the value of a y value of 1 and once to be at the y value of 3. As opposed to over here, the x value of 2 was only at the y value of 3. There was no other, if I follow this vertical line, I don't touch this graph at any other spot. So that is a function. That's the difference. Okay, and it's only vertical line test. You don't have to worry about horizontal. Okay, so those 4, E, J, N, and R, are not functions because they fail the vertical line test. So part of your homework is going to be for you to be able to identify those graphs that are not functions, draw a vertical line through it, label it not a function. Okay? Another part of your homework tonight is for you to determine graphs which are continuous or discrete. So we've got, let's see, I want to blow this up a little bit. Okay, graph A is, if I put my pen down on the line, I am tracing the line the whole time, and it is continuous. Graph B. Sorry, we had a little announcement. I couldn't get the pause button in time. Okay, graph B is also continuous. Okay, if I come down here to graph F though, graph F is what we call discrete. It is discrete because we have individual points that are not connected. So you will have to differentiate on your homework tonight between continuous and discrete. Another vocabulary word I would like you to use in describing graphs in homework tonight would be whether your graph exhibits straight lines or curvy lines. Straight or curvy lines. F, if I was going to do straight or curvy, it's hard to tell on this graph, but if I were going to connect these, it kind of looks straight, but once we get into the chapter about parabolas, you're going to understand, well, that's not really straight, this is actually curvy. And lastly, or the third thing, we did some extra stuff in class, but I also want you to talk about the behavior of the graph in terms of, is it increasing, decreasing, what? So for graph A, I would say it is decreasing, then it's constant, then it is decreasing some more. And we can use arrows for this. Graph B, we could say it is increasing, and then it is decreasing. Graph F, we could say it is increasing, then decreasing. Okay, so if we flip to our homework assignment on this, oops, too far. Okay, vocabulary should be done. Alright, so this one problem set for this set is asking you to take two graphs and compare them. Okay, some of the ones that I kind of glanced at, people showed me in class today, I'd really like to see you put a little more quality into this and have some more vocabulary being used. Okay, so up here, somebody in class today just said on one of the graphs, well, it's moving left to right. Well, all graphs are read from left to right, so that doesn't really explain with enough detail. If we look at our example that's given to us, let's look at the vocabulary we see in there. We see vocabulary in there talking about, where's my highlighter? Talking about the decreasing behavior from left to right. Okay, both graphs are functions. Both graphs are made of straight lines. There's three different vocabulary words, three different things that these graphs have in common. So put a little more quality into how you answer these questions. So if I was doing number 2, I wouldn't just say both of these graphs are U-shaped. Okay, you could. Both graphs are U-shaped. Okay, but I could also say both graphs are continuous. I could say both graphs are functions. Okay, try to find everything in common that you can between the two graphs. Don't leave it at just one thing unless that's all there is. Okay, moving ahead to the next section. This is an easy section. Is it discrete or continuous? Okay, don't overthink that. Alright, and the last section is you're just applying the vertical line test. So this graph is a function I'm going to say for my directions, if you say it is a function, you can just leave it at that. If you're going to say it's not a function, then I want you specifically to draw a negative or a vertical line somewhere in it and then say not a function. I don't want yes or no. Not a function. Okay, number 16 is a function. Okay, so the next stuff that I talked about in class was about domain and range. If we go back in our textbook, we look at the textbook definition. Domain is your set of input values. Okay, that's a fancy way of saying your x values. And your range is your output values. I kind of drew over that by accident. Okay, y values, guys. So what we looked at in class today was we went back and looked at our group of graphs. Okay, and I'm just going to pick a couple to do, because this is kind of above and beyond what's in this lesson, and it is stuff that we will definitely talk about tons more throughout the year. So let's say I was looking at B. So if these are all calculator generated images, they don't have arrows on them, so let's assume that they go on and on forever. Domain would mean if I put my pen on any point of the x-axis and I moved up or down, would I touch the function? So if I was here, I could go up and touch the function. If I was here, I could go down and touch the function. If I'm way out here, it looks like I can't go down and touch the function, but that's a limitation of the size of the picture. This arrow indicates that it is going down at an angle. So that means that eventually I would get to a point where I could drop a vertical line down and touch the graph in both directions. So the domain for this graph, there's no limitation on my values for x. So I would say it's all real x. Now the word real threw some people today because it seems like a strange word. Real means any number, any kind of number. It could mean a whole number, a positive number, a negative number, a fraction, a decimal, a percent, a square root, any possible kind of number with any number of decimal places. Okay, all real x. And we would say that because if we were trying to make a list of all the possible values I could put in for x, well, you know, this graph is counting by twos. The textbook said so. That the graph is counting by twos in both directions. So here's the 2. Okay, yep, 2 counts. Halfway between that, that would be 1. Well, that counts. Halfway between 1 and 2 would be 1.5. In fact, any point along here, whole number or decimal. Okay, that's what real number means. It means it can be any decimal of any size as a value for x. Okay, range. Range is all the y values. Now, sometimes the range of a graph is all real y because there's no limitation, but clearly this has a limitation because if I put my pen up here and I go to the left and to the right, I am never going to touch the function up here. I will down here. I can touch it this way. I can touch it that way. I can touch it here. Right on. I can follow it across to here. So basically this seems to be, this is what's called the maximum point right here, the vertex. Okay, this is the value of y equals 2. The graph goes no higher than 2. So there's a limitation. It's all the y values that are less than or equal to 2. So all the values on the y-axis that are less than 2 count in the range. Okay. Let's look at the discrete graph f for a second. In 5th period, I pretended it was a graph that went on and on forever. But in 8th period, we pretended that it was not a graph that went on and on forever. So if we're going to do domain and range for this, I kind of like the way I did it 8th period better. Domain in a discrete graph, if this is just all the data that there is and it does not go on and on forever in both directions, the domain would be listing all the x values for each point. So for example, the coordinates of this point is -2, -8. Okay? This one is +2, -8. This is -1, 1. This is 0, 4. And this is +1, 1. Domain would be the x values. -2, -1, 0, 1, and 2. It's a discrete graph. It's not real numbers, because real numbers would include decimals and fractions and stuff, and we're not including those things. We did not connect those dots. That means that it can't be a decimal. Range. That's where I would list the y values. So -8 is a y value. 1 is a y value. 4. 1, -8. Now some of these y values got listed twice, and that's okay. Alright. That would be another way you could do domain and range for a discrete graph. Okay. This is not the domain and range part that you see that I'm talking about right now is not in your homework assignment, so don't stress over that. But it's something that we will talk about and revisit and revisit and revisit as we talk about all the different kinds of graphs throughout the year. Have a great day, and I will see you all tomorrow.